Hello, my name is Mark Ellis from Stick and Rotor Studios, and today in this video I'd like to show you some of the advanced Lua integration that we've done for the remote virtual device that's going to be available in 1.7.0 Beta 13. These new integrations will allow you to create custom widgets and custom keys, things like gauges, things of that nature that you can put on the remote virtual device. I will caution you, in order to be able to do this, it does require some programming skills. So for those of you who don't necessarily have those skills, you might find this video a little bit overwhelming. But bear with me. If you're interested in learning, you can pick it up. The scripts are very well commented and documented. And even if you don't do the programming yourself, I'm sure what you're going to find is those of us who use X-KeyPad can do the programming. We'll create some of these widgets and controls and gauges and stuff and publish them and make them available for other people to use. But it would be good for you to understand the concepts of how it all works. So to get started, let me give you a walkthrough of exactly what you can do with this, what it looks like visually. And I've enhanced the remote virtual device Cessna 172 example so that it has some of these gauges and custom keys on it, as well as the corresponding Lua scripts that drive the rendering and some of the interaction with these, with these custom keys. So with that, I've got X-Plane 11 up here. I do have the sound turned down on it so that it doesn't interfere with my voice. And the first thing I'm going to do is I'm going to install the Lua scripts that go along with this. So we're going to come up here to X-KeyPad. We're going to bring up the Lua script configuration editor, and we're going to do an append. And these are located under Resources, Plugins, X-KeyPad, Samples, and then you want to go to the Remote Virtual Device one, Cessna 172, and here is the JSON file that has the Lua scripts in it. And you're going to see here that we've actually got 4 scripts, and you'll actually see these widgets in the remote virtual device in a minute, but this script drives the radios and the GPS knob. This one drives the map, which has got the traffic map on it. Another one draws the test shapes, and the last one is for the directional gyro widget that we've created. So now that we've got that installed, let's save it. And now let's bring up the X-KeyPad configuration editor. And again, we don't have anything in here, so let's do a file append. And again, it's in the same place, Resources, Plugins, X-KeyPad, Samples, Remote Virtual Device, Cessna 172. And we'll open this one up. And now we've got all that in here. Okay, and let's go ahead and take a look at how that remote virtual device looks for this particular thing. So I'm going to come over here. Give me 1 minute. We're going to go to X-Plane 11, Resources, Plugins, X-KeyPad, Remote Virtual Device, Windows, or whatever operating system you're on, and we're going to fire up the remote virtual device. And let me drag that over here so you can see it. And this is what it looks like. And you'll notice, if you're familiar with the previous remote virtual device display, you'll notice that we've added a few extra things here. One, we have a directional gyro widget that we've created, and I'm going to actually use this as the primary thing to walk through for the demo and an explanation of how this works. And with this particular widget, we've got some interesting things. If we scroll with the mouse wheel, you'll see that that can adjust the heading bug. You can also just click here at different parts of the directional gyro, and it will adjust the heading bug based upon where you clicked. Okay. You can also come down here. You can do an alignment of the directional gyro by scrolling. And you'll notice that if I've got it really out of alignment with the magnetic compass more than 4 degrees, this will flash, and we can zero it by simply clicking on the center button here, and that will give us a synchronization to the magnetic compass for the TG. We also have a traffic map that we've created here. This is showing you all of the traffic with an X-plane relative to where your plane is. So I didn't do this. I probably should draw a little aircraft in here with the nose going in this direction. But this is the traffic relative to your plane, as if you were, facing forward and looking out the windshield. And if we hover over the top of these little targets here, we can see that that's an SF-50. It's at roughly 13,000 feet, and it's descending at roughly 2,600 feet per minute in a descent. I could also hover over this one. Here's an S-76, 3,000 feet, and it's not really going up or down. It's basically got 0 feet per minute for for a vertical speed. We can adjust the range here by, if I click up at the top here, it's going to bring the range in. If I click at the bottom, it brings the range out. And I can also scroll with the wheel, to bring the range in and out. We've also done some interesting things here with this big page and chapter knob for the Garmin 530. As I hover over the top of the outer ring, you'll see that that's got a little highlight around it. And if I click on this ring or scroll on that ring, it will adjust the Garmin 530. This brings me into the inner ring. And if I hover right over the top of the push button, then I get the push button. And this gives you a visual indication of when you click, what's it going to do. Also up here in the radios, we've done some interesting things here that if I use the scroll wheel, I can scroll the fine frequency up and down. If I move the cursor over to the left half of the display or the radio widget, if I scroll, it can move that course frequency up and down. I also can click. If I click on the top half, it'll move it up. If I click on the bottom half, same with the fine frequencies, and that works for all of the radios. And the last thing I've done is I've actually given you a demonstration on the page here, which shows you all of the shapes that you can draw, with this Lua integration. Here I've got basically, this is showing you how you can draw lines, and I happen to draw a square wave with this. You could do circles, and circles with filled, rectangles, triangles. This is basically what we call an n-gon, so you can give it the number of sides you want, and it will create a shape with that number of sides, like a pentagon, hexagon, whatever. Here's a polygon, multi-sided shape that's closed at the end, so you can either fill it or not. And here's an ellipse, and an ellipse with a rotation angle on it. So there's a lot of shapes that you can draw using the Lua script integration. Okay, so that gives you an idea of the widgets that we've created on the remote virtual device that you could use as an example. And what I would like to do now is kind of walk you through how do you get this all hooked up. And I'm going to only walk you through one script. We'll do the DG, which I think is fairly straightforward. It uses pretty much all of the capabilities, and then you could look at all the other scripts and see how they work. They're all pretty well commented. So let me move this out of the way over here. We'll curl these out here. That's because that came up because I was adjusting the DG. And the first thing I want to show you, if we come down here on the remote virtual device, let's go to the DG. I want to show you two new fields that get added here. One is a Lua on key function, and the other is a Lua on draw function. Normally, you would leave these blank, which means that this particular action has got no integration with Lua, whatsoever. Whatever gets rendered on the key is all defined in the, the DG function. What happens when you click on the key is all defined in what you have up here in this function in that key definition. If you do decide to do it with Lua, what you're going to want to do is put your function names in here that you want called, and I'm going to actually show you where you define those. But say, for instance, on the on key, the Lua function actually takes a number of different parameters, and we'll look at these in a little more detail. You get the key state, when the on key came down, and the key state could either be 0, indicating the key went from down to up, 1 indicating that the key went from up to down, and if it's 2, it means that you're actually scrolling with the scroll wheel. The function name that gets passed in is going to be this one right here, right? you get the X and Y of where the cursor was when you clicked or scrolled the mouse, and that X and Y is relative to the key. So if the key is say 100 pixels wide by 100 pixels high, this X and Y is going to be between 0 to 99. The width and height is the width and height of the key in pixels. And the clicks is if you did end up with a scroll event, the clicks will either be a positive number, indicating that you scrolled in one direction, or a negative number indicating that you scrolled in the other direction. And you can use that click value to increase or decrease data refs or execute a command a certain number of times, whatever you need to do. The DG on draw function gets called, it's roughly every 100 or so milliseconds it's going to get called. And here you have an opportunity to create what we call a draw list, which is a set of instructions like draw an image, draw some text, draw a rectangle, whatever you need to do. And you could load this draw list up, with the things that you want to render inside the key. And that is going to be in addition to anything that you may be drawing, with like background images or background colors or background text that you actually put in the key definition. You could potentially put nothing on that key and do it all in Lua, or you could use kind of an interesting combination where some of the drawing you do in the key and some of the drawing you do in a Lua script. The main thing to remember is the order in which things are going to get drawn are first anything that's defined on the key, like background images, background colors, label text. Then anything that you add in your Lua on draw function, and those are going to get drawn in the order that you add them. And we'll see that in just a minute. So this is where you hook up your Lua script, to that particular key. So what I'm going to go ahead and do is just make sure I've got that saved. I'm going to close that. And I'll actually come in and take a look at the DG function. And I'll make this bigger so that we can see it a little bit better. Okay, so we've got some comments up here. And one of the things with the DG, and I'll just bring this over here to show this to you one more time real quick. This DG is actually made up of a few images. And I'll actually take a look at the images in a few minutes. So the trick with this is rendering the images in the right order. And some of the images, by the way, do have a transparent background because they're getting overlaid over the top of each other. Some of them you actually want the image below to show through. A good example of that is going to be this little plane here with the red and the little markings. Everything is going to get drawn below that, and you want the background of this thing to be transparent so that the images underneath, can get transmitted through. Same is true with the heading bug. You'll actually see this image in a minute when we look at it. It's just this little green square, and the rest of the background is all transparent so that it transfers through. And the trick with this Lua script is when you draw an image with the Lua script, you actually have the ability to give it a rotation angle. So if everything was perfectly facing north, in other words, you were heading perfectly north magnetically, and your heading bug was facing north, then you wouldn't put a rotation angle on anything. As the plane moves and you're at different headings, you're going to want to rotate the image for the card around based upon the magnetic heading that the DG is indicating. And the heading bug image, you're going to want to rotate that based on where the heading is located. So let's take a look at these images real quick, to see how that is. So they're actually right in here in the image script. And here, if we hover over there, there's the heading bug. You notice that it's nothing but a little green rectangle towards the top. And that blue area is basically a transparent background. The heading, this is the heading background. That's basically the casing of the directional gyro. There's the card, which is basically the heading card that we're going to rotate around based upon the DG's indicated magnetic heading. Here's that little airplane with the kind of red markings around the dial. And we're going to use these four images together, to draw that directional gyro. You'll also notice we have some other ones here too, like that GPS knob. Here's one with the cursor button highlighted. Here's one with the inner ring highlighted. Here's one with the outer ring. And here's one if you're not hovering over the top of the key at all. So you get kind of the general concept as to how this works. All right, let's go back over to the DG definition, and let's take a look at what we've got here. So there's a fair number of comments here. The first thing we're going to do is, let me just come down and show you that at the very bottom, you have to register your on-key and on-draw functions. So here we've registered our do-on-key function, and here we're going to register our do-on-draw function. Okay, so let's take the do-on-key first. Let's actually go through that function and talk about what it does. And let me again give you a quick demonstration. So if I bring this over here, if I scroll anywheres in here but not on this little knob, it's going to adjust the heading bug. Okay? If I click anywheres in here, it's going to calculate the tangent and the angle that I clicked on and use that calculated angle to set the heading button accordingly as to where I clicked. If I scroll anywheres within this knob area here, that's going to adjust the magnetic, basically it's going to adjust the DG so that you can align it to magnetic north. Okay, and if I click while I'm in here, that's going to basically sync your DG to magnetic north. So we want our on-key function to be able to deal with all of this. So let's go back over to the script and take a look at it. So here's our on-key function. If you remember correctly, it takes a number of different arguments, okay? It takes a key state, which is a number. 0 means key up, 1 means key down, 2 means a wheel scroll. It also gets the function name, which is going to have, in our case, I think the function name is DG. We're not actually using that here because we've made this DG on key function unique to the DG. We could, for instance, if we had a number of keys that all kind of did the same thing, we could identify which key it was simply based upon the function name that gets passed in. Lastly, we have our X and Y values of where the mouse cursor was when you either scrolled or clicked, the width and the height of the key in pixels, and if it was a scroll event, is the number of clicks you did with the scroll wheel. Positive indicates a scroll in one direction, and negative indicates a scroll in a different direction. Okay? So, the first thing we do here is we come in here and we say, if scrolling, then either adjust the DG or the heading bug based upon the wheel clicks. So the first thing we do is we say, if the key state equals 2, means we're scrolling, then we want to check if the X is greater than or equal to 25, less than or equal to 61, Y is greater than or equal to 173, and Y is less than or equal to 208. And if that's the case, that means that we are over the top of this. Now you might ask, how did I come up with those magic numbers? Well, what you do is you open up this image here, this background image in something like Paint or something else, where as you hover over the top of it, or if you do something like select it, you can actually see the X and Y values of what makes up this, where this is. So that's how you find out, where it is. I will caution you, one of the challenges with the way I did this particular coding on this on key, this image has to be the size that it is. If you try to set this remote virtual device to do something like fit to the size of the screen, like if I make this bigger and this whole thing gets bigger, then this isn't going to work because it's hardwired, okay, to the mouse coordinates being at that particular place. You could enhance this to know what the original size was and then scale those coordinates based upon how much bigger the width and height was versus what you originally planned on it being. So you can scale it up and down, but there's a little more math involved. I chose to keep this relatively as simple as I could for the purpose of being able to explain this as a demo and a sample. So when we see that the mouse is within this area, we know that what we're dealing with is the directional gyro drift, and we're trying to adjust that. So all we're doing here is taking the current value of the directional gyro, which is if we come up to the top here, you could see where we define those data refs, right? DG drift, that's the data ref for the DG vacuum, drift data ref. and come back down here. And all we're going to do is take it and subtract the number of clicks from it. So if the clicks are positive, it's going to take away from it. If they're negative, it's going to actually add to it. So that is what's going to adjust the drift as we scroll the wheel. If it's not that, then we're going to adjust where the heading bug is located. And the heading bug's the same thing. It's got a data ref associated with it. Let's come back up here and look at that real quick. Here's the heading bug, Sim Cockpit Autopilot Heading Magnetic. And we do the same thing with that, right? Just simply take its existing value, add or subtract the clicks depending upon whether they're positive or negative, and that's going to adjust the bug as we scroll the wheel. If it's not a scroll event, then what we're going to do is take a look at where we clicked. So first we're going to say is key state equal to 1, which means that the mouse, basically the left mouse button go down. We're going to do the same thing. We're going to say, are we within that area of the little DG adjust knob? And if we clicked on there, we're going to send this command, sim instrument DG sync to magnetic. And that's basically, you know, when we come in here and we click that, that's what's syncing it. And I'll scroll it to adjust it. Click on it, and it syncs the directional gyro to wherever the magnetic compass is currently set to. Okay, if it's not that, now what we're going to do is we're going to use the X and Y along with the width and height, and I'm not going to try to get into great details what the math is here, but effectively what we're trying to do is come up with the arc tangent of where you clicked relative to the center. What we're really trying to do is calculate the angle from the center to where you clicked the mouse. And that angle that we actually end up calculating here in degrees is going to get used to turn around and adjust what the heading bug should be, right? So I won't get into the details of the trigonometry that's involved with this. This is something you could look at and look up, but if you're familiar with trig, you'll understand the concept of the tangent being the opposite over the hypotenuse and trying to calculate that angle. But you get the basic concept, right? And that's what sets the heading bug based upon how I clicked. And again, I'll demonstrate that to you really quick. Like if I click over here, what it did is it calculated the angle from, assuming that that's 0 degrees, then that's going to be, you know, roughly, what is it, 45 or whatever, you know, and it simply uses that angle to figure out what do I need to set the heading bug to. Okay, so that is our onKey function, all right, and that's what that does. Now let's take a look at the onDraw function, and that's down here, draw DG. Okay, so the first thing we do in the draw DG function is we're going to come in here and we're going to get a local variable called bug, which is telling us, you know, where the heading bug is relative to where the card is. If you remember correctly, the heading bug is always displayed, you know, relative to where the card is actually rotated. So I mean, if everything was perfectly north, then the heading bug at 0 and the DG being at 0, it's going to be at 0. If the DG is at 10 degrees, but the heading bug is at 20, the heading bug's got to get rotated a little bit further to the right, you know, to make it so that it's relative to where the DG card is. So we're using this little local variable here to find out what the difference is between the bug and the heading, because we're going to use that. That angle is kind of like an offset. We also have a function here, okay, called get remote virtual device cursor data. This allows us, this is the time we call the onDraw, you know, if we're over the key, give me some information about where the cursor is. And over key is going to tell us that if over key is set to a 1, that indicates that the cursor is actually over the top of the, you know, the device and over the top of the key. And if it's a 0, it indicates that it's not. And we're going to actually use this to do this highlighting. If you'll notice here, when I come down here, as soon as I hover right over the top of this, that is putting a little translucent filled in circle over the top of it. And we're going to use these calculations here that get RVD cursor data to tell us what's going on here and knowing when we should or should not draw that little circle. And you'll see that in a little minute. Okay? Okay, so the first thing we do is we're going to come in here, we're going to do some calculations here in this bug. basically trying to make sure that this is always a true angle that's basically going from 0 to 359, because we don't want it to be like 370 or minus 20 or whatever. We need to keep it within the 0 to 359 range for our calculations to work out pretty good. So the first thing we do is we clear the draw list. Now, this concept of a draw list, it's basically a list of drawing commands. Draw an image, draw a circle, draw a square, draw a line or a set of lines, okay? And you'll actually see this if you go look at the drawing shapes example, right? And this draw list, you populate it with the things you want to draw in the order that you want them to be drawn. Now, the idea of clearing the list is, we're not doing it in here, but if you look at the map, you're going to find out that I only update the map every 5 seconds. And this is simply because I don't want to overwhelm sending data to the remote virtual device at a rate faster than we really need to visually see it. If the map updates every 5 seconds, that's perfectly fine, okay? You also want to do that if the draw list can get kind of extensive. And in the map, if you have a lot of targets around, there's a lot of little things we're drawing on there, like all those little diamonds about where the traffic is. You know, here it's not such a big deal because the number of things we're drawing, it's really just a few images and some text. And the remote virtual device, or X-KeyPad, is pretty smart. It knows that if you created a new draw list and that draw list is exactly the same as the one you did before, it's not going to bother sending it back over to the remote virtual device because it's already got it. It's cached over there. It's using that on every frame that the remote virtual device gets drawn. It uses that to do that. But in our case, we're going to clear it out and we're going to start all over again and create new images. So the first thing we're going to do is we're going to add the background. And if you remember correctly, let's quickly come over here and look at it. That's the background. We need to draw that little kind of casing for the DG. So we draw the background, and we do that by adding an image and then setting the image ID based upon that file name for that background image. Then we're going to add another image. We're going to add the heading indicator card, which is this one here. That's the one that we have to rotate based upon the DG's magnetic heading. So notice that we add that, and then what we do is we basically set its rotation angle, and we're going to round that to the nearest degree. And again, the reason being is that we don't need to be showing it to a 1/10 of a degree setting. You know, if it's within 1 degree, that's good enough. You could not round it, you could make it very accurate, but then, you know, what happens is the darn DG moves 1/10 of a degree and you're sending new draw data over to the remote virtual device. You know, you don't really need it to be that smooth, and it will impact performance to a small degree, but I just made it here so that it's efficient, because if it's changing 1 degree, that's good enough for me, okay? And, you know, again, we've got some calculations here based upon, you know, how we did our math up here. It's really telling it which direction we need to rotate it. Do I need to rotate it left, or do I need to rotate it right, okay? The next thing we're going to do is we're going to add the heading indicator, basically the plane, which is that guy there, right? Because that goes over the top of it. And then the last thing we're going to add is the actual heading bug, okay? And that's done right here. And again, we set the rotation angle of where the bug is that we calculated up over here, okay? And that's going to rotate the heading bug angle around. Last thing we're going to do is we're going to add some text here. And these coordinates of 97, 106, that just happens to be the perfect center, or almost the center, I think it's like right over here, of where we're going to draw the magnetic heading that the DG is indicating. We're going to draw the text of that number there. So we basically create a string, we format it. It's going to be 3 decimal places, always with leading 0. So if the heading is 010, you're going to see the 0 in there. We're going to round that heading up to the nearest degree. And then what we're going to do is we're going to set the color. The colors on here, you basically give it 3 floating point values: red, green, and then blue. And again, these values go from 0 to 1.0. So If you make it 1.0, that's like full on, green here. If I did a 1.1, that would be red and green, which is going to give you yellow. So you could look this up. There's color wheels that show you what the values are. Okay. There is an optional alpha value for a fourth one. That allows you to just determine how translucent that color should be, how much of the background should actually show through with that color. I'll actually show you where we use that, but it defaults to 1, which means don't show anything underneath it. Just draw that right over the top of it as a really kind of a hardwired full-on color. Okay? And then we have a little if statement here. If the DG is indicating heading more than 4 degrees difference from the magnetic heading, and we actually look at that here, there's a magnetic heading data ref that tells me from my flight model what am I actually heading at. If there's a more than 4 degrees difference, what I'm going to do is add an additional color here, which will be the flashing color of that text. Okay? So that it flashes if the DG is out of sync with the magnetic compass. Okay? And last thing we're going to do is we're going to set the font that we want. We're going to use a 7-segment font, 15 points. Okay, and that's has to be one of the fonts that we've got defined in the system. Okay, and then we're going to check one more time here. If the cursor happens to be over the top of that little knob, like right here, if it sees the cursor's over top of it, I'm going to draw a translucent yellow circle over the top of it. So here we make that if statement. If we're over the key and the X and Y are over that little round DG adjust knob, then we're going to add a circle. The coordinates are 44, 191, which is the center of that circle. The size of the element is going to be 19 pixels as a radius. We don't really have a height for a circle. It's based on radius, not width and height. And then we're going to add a couple of colors here. The first color is going to be yellow. And you'll notice here that this time I got a 0.5 for my alpha value, which means that it's going to be 50% translucent, so that the underlying image there is going to show through a little bit. Let me see if I can actually bring that back here real quick. See how the push, that image is showing through there? That's because I'm making this yellow circle 50% translucent. Get rid of those. Okay? And with circles and shapes, if you add a second color, that means you want it to be filled in, right? One color would just give you a circle with not being filled in. A second color that we've added here means I want it filled in. And you could have the line, the outline be a different color than the filled in color. In my case, I made it the same. Red and green, which gives me yellow. I set the blue component to 0, and then again 50% translucency. So that's how we end up drawing this directional gyro. All of the scripts are pretty well documented, and I added a lot of comments here as to exactly what these arguments do. And if you look at the test shapes example, that's going to show you all the different shapes, okay, that you can draw. It's, again, pretty self-explanatory as to how that works. I will be doing a much more detailed documentation on how this works, but I think if you use these examples and you take a look at these scripts, you get a pretty good feel for how it all works. And again, in closing, this is not something that everybody's going to do. It gets a little complicated, but you can do some pretty amazing things with it if you want to enhance your devices. I am also planning on taking a look at doing the same thing using scriptable vector graphics images, SVGs. If I can get that to work with the SVGs, then what that means is on your Stream Deck, we could probably do something similar with being able to draw, have dynamic backgrounds on your Stream Deck keys, because they do actually work with SVG files, or at least that's what I've been told. So I'll try to expand this a little bit further so that it'll work with Stream Deck keys and maybe even a little panel on the Stream Deck Plus encoder panel, touch panel that you've got there. Okay, so I know this was pretty fast and it got into a fair amount of coding detail. I hope I didn't overwhelm you with it, but I did want to show you what you can do with these new enhancements in 1.7.0 Beta 13. Thank you very much for watching.